Okay, so we're on section 5.5 and this is called first differences. So let's just talk about what first differences are. So what first differences are is if you have a table, what you're going to do is you're going to take the difference between the consecutive y values and you have to have your x values evenly spaced. So let's look at this table as an example. So what I mean by evenly spaced x values is the x values has to be going up by some sort of scale. Here it's going up by ones. It has to be consistently going up by the same scale. It could go by twos or fives as long as it is consistent. Okay, so what we're going to do is we are going to take the difference between the y values. So taking the difference means you're going to subtract them. And when you take the difference between the consecutive y values, so the ones right after each other, if all those numbers are the same or constant, that's what constant means, the same, then if you graph it, it will be a linear relation, which means it will be a line. If you take the difference between these consecutive y values and they are not the same, then it will not be linear, and we call that nonlinear. Okay, so what you're going to do is you're going to add another column here, and you're going to call it first differences. Okay, so once again, I look at my x's. Is it going up by some sort of scale? And it is. Then I start taking the difference between my y's. So I usually go from bottom up. So I'm going to do 4 take away 1, and I get 3. And then I'm going to do 1, and I'm going to subtract negative 2. Be careful when you subtract negatives because that's the same as adding, and that also equals 3. Negative 2, I'm going to subtract negative 5. Once again, you subtract a negative, which is the same as adding. So negative 2 plus 5 is 3. And then negative 5, and I'm subtracting again a negative. So when I subtract a negative, again it's like adding, so negative 5 plus 8 is 3. And what you should notice is these are all the same number. So that means my first difference is constant, and because they are constant, I know if I were to graph this, I would get a line. So this is linear, which means it's going to be a line when graphed, since the first differences are the same. Okay, let's do the same idea here. A different table. I want to test whether or not if I graph this, this will be a straight line. So once again, I do another column called first differences. Right, got the S there. Then once again, I look at my x's. Is it going by some consistent scale? And it is. It's going up by ones. So now I take the difference between my y's again. So 8 take away 4, 4. 4 take away 2, 2. 2 take away 2, 0. 2 take away 4, negative 2, and then 4, and I take away 8 is negative 4. Now I look at my differences and I notice these are not the same. And because they are not the same, I know if I were to graph this, it would not be a straight line. So we call that nonlinear. And so I say this is nonlinear since the first differences are not the same. Okay, so I also took each of these tables and graphed it. So if you take the first table here and if you graphed it here, I get a straight line. I take this second table here and I graph it, I get this curve. But the point with this table is it doesn't need to be graphed. I can determine whether or not I have something linear or nonlinear just by taking the first differences. So the graphing is not necessary. Okay? So let's just do some conclusions of things that you should know at this point. Okay, so to determine if something is linear or nonlinear, if I only give you a table like this, and I asked you linear or nonlinear, well, what would you do? You would do the first differences. So if the first differences is the same, it's linear. Not the same, nonlinear. What if I gave you just a graph? You would look at your graph and you'd say, oh, if I have a straight line, I have something that's linear. If I have something that curves, I have something that is nonlinear. Okay, so if the graph is a straight line, it is linear. If the graph is a curve, nonlinear. The last thing you're going to have to be able to determine just by looking at it, so this is by looking at your table, by looking at your graph, now see with an equation. Okay, so with an equation, you have to look at your x and y, okay? And you look at the exponents. Remember, this is your independent variable and this is your dependent variable. If both the independent and dependent variable have exponents that are 1, it is linear. Remember, there's an exponent on this y and there's an exponent on this x. We just never write it. It's understood to have a 1 here and it's understood to have a 1 here. So I know if I have a 1 on both the dependent and independent variable, the exponent is 1, then I know it's linear. If it's not, then I know it's nonlinear. So if you had something like, let's say, for example, I don't know, y exponent 2 equals 3x, like that. X has an exponent 1, y has an exponent 2. I know this is nonlinear. Okay, so let's look at a couple of examples where we'll think about, is this linear or nonlinear? Okay, so let's look at each of these. Okay, the first one, y equals 3x minus 4. So looking at the equation, so what you should be looking at is your y and your x. Looking at the exponents on them. There's a 1 understood here, there's a 1 understood here, and because of that, it is, exponents are 1, so it is linear. This is also a partial variation because of that minus 4. Okay, let's look at this one. Y equals 0.5x. Again, look at the exponents on x and y. What's the exponent on y? It's a 1. Exponent on x is a 1. It is linear. Not only is it linear, it's a direct variation because my b value is 0. Okay, let's look at the next one. Y equals x squared minus 4. So now again, I look at the exponents on x and y. The y has an exponent 1. The x has an exponent 2. Because of that, it is nonlinear. Okay, next one. Next two, let's look at these last two. 3x minus 4y equals 12. Again, look at the exponents on x and y. That x has a 1, this y has a 1, so this is linear. Okay, let's look at this one. Y equals 1 over 3x. Again, look at the exponent on the y, it's a 1. The exponent on the x is a 1, so this is, once again, linear. Let me just add one more. Y equals 2 to the exponent x. Let's look at that. The exponent on y is 1, but then I notice my x is an exponent. That is not linear. This would be nonlinear. Okay, that's it.